In less than 2 weeks, OpenAI released GPT-5.6. A Chinese artificial intelligence model became so popular that its company temporarily stopped accepting new subscriptions. Google reportedly delayed its next flagship Gemini model, and Samsung created an entire division dedicated to robotics. At the same time, governments are forcing major technology companies to open their platforms, restricting the construction of enormous data centers and preparing international talks about the risks of advanced artificial intelligence. The AI race is no longer only about who has the smartest chatbot. It is becoming a competition for agents, chips, electricity, robots, distribution, and political influence. Today is July 21st, 2026. These are the 6 artificial intelligence and technology stories that matter most right now. We will begin with OpenAI, continue with the sudden rise of Kimi K3, and finish with the increasingly uncomfortable question of how much physical infrastructure the artificial intelligence boom actually requires. OpenAI released GPT-5.6 on July 9th. But the most important part of this release is not another collection of benchmark improvements. It is how clearly OpenAI is repositioning its models around long, complicated work. GPT-5.6 is divided into 3 versions named Sol, Terra, and Luna. Sol is the most capable option for difficult tasks. Terra is positioned as the balanced model, and Luna is designed to be faster and less expensive. ChatGPT Plus users can access all 3 through ChatGPT Work and Codex, select different reasoning levels, and enable the maximum reasoning setting. The application programming interface also introduces programmatic tool calling. This allows the model to create and execute temporary programs in memory, coordinate multiple tools, and process intermediate results before producing a final answer. OpenAI is also testing multi-agent execution. Instead of assigning an entire task to one model, GPT-5.6 can launch several sub-agents concurrently and then combine their work into one result. That detail is more important than it may initially sound. For the last few years, artificial intelligence companies competed mainly on the quality of a single response. Now they are competing on how much useful work a system can complete before a human needs to intervene. The important question is no longer simply, can this model answer my coding question? It is, can this model inspect a repository, plan the work, coordinate tools, implement the change, run tests, correct its mistakes, and return with a completed result? GPT-5.6 is OpenAI's clearest attempt yet to make that workflow a central product rather than an experimental feature surrounding a chatbot. While OpenAI was launching its newest closed model, Moonshot AI introduced Kimi K3 in China. Moonshot describes Kimi K3 as a 2.8 trillion parameter open-weight system focused heavily on coding, knowledge work, and agent-style tasks. Demand became so intense that Moonshot temporarily stopped accepting new consumer subscriptions only days after launch. The company said usage had exceeded its forecasts and was approaching the limits of its available computing clusters. Moonshot redirected capacity toward existing paid customers and began reorganizing its subscriptions into separate general-purpose and coding-focused memberships. This is simultaneously an impressive success and an important warning. Open-weight models are often presented as the accessible alternative to closed systems from OpenAI, Anthropic, or Google. Their parameters can theoretically be downloaded, inspected, modified, and deployed independently. But a system containing trillions of parameters is only theoretically accessible to most users. Very few individuals or companies can afford the infrastructure required to serve something that large efficiently. Kimi K3 therefore represents a strange new category. It is open enough to inspect and customize, but large enough that most users will still depend on Moonshot or another major cloud provider to run it. The capacity problem also demonstrates why agentic coding is so expensive to operate. A normal chatbot may require one request to answer a question. A coding agent can repeatedly inspect files, call tools, generate code, execute commands, encounter errors, and try again. One user session may produce dozens or even hundreds of model calls. That means agent-based products can consume far more computation than ordinary chat, even when the underlying model is advertised as affordable. Kimi K3 may be one of the clearest signs yet that Chinese open-weight models are no longer merely cheap alternatives. They are becoming serious competitors, and their popularity is beginning to expose the same infrastructure limitations faced by American artificial intelligence laboratories. Google, meanwhile, is facing pressure from 2 completely different directions. First, Bloomberg reported that Google delayed the launch of Gemini 3.5 Pro because the model had not yet met internal performance targets, particularly in coding. The release is reportedly several months behind schedule. A delay does not mean Google has lost the artificial intelligence race. The company still controls Android, Search, Chrome, YouTube, Google Cloud, Gmail, and one of the largest artificial intelligence research organizations in the world. But that enormous distribution advantage is now attracting greater regulatory attention. The European Commission has required Google to make parts of its ecosystem more accessible to competing artificial intelligence assistants and search engines. Rival assistants could eventually receive deeper access to Android functions, subject to user permission and security requirements. Competing search providers may also receive access to certain anonymized data used to improve Google search. Google argues that these requirements could weaken privacy, security, and product quality. European regulators argue that they are necessary to prevent Gemini from gaining an unbeatable advantage simply because Google controls the operating system and search platform around it. This may become one of the most important battles in consumer artificial intelligence. The technically strongest model does not automatically win. The assistant already connected to your phone, browser, email, search engine, documents, calendar, and payment methods may be much more difficult to replace. The European Union is now attempting to ensure that Google cannot permanently reserve that advantage for Gemini. The next major artificial intelligence platform may not be a website or an application, it may be a robot. Samsung announced today that it is creating a new division called Robotics E-Experience. The division will report directly to the company's chief executive and oversee robotic strategy, research, core technologies, and commercialization. Samsung also plans to establish robotics research hubs in the United States, China, and Japan. Its initial focus is expected to include humanoid robots designed for manufacturing, with possible future expansion into retail and household applications. This is part of a much broader movement toward what the industry calls physical artificial intelligence. Physical artificial intelligence refers to systems that do more than generate text, images, videos, or code. They perceive an environment, make decisions, and perform actions through a physical machine. That is significantly harder than operating inside a browser. A chatbot can generate an incorrect sentence and try again. A robot working beside a human cannot casually hallucinate the position of a wall, a machine, or someone's hand. Progress in robotics will therefore require much more than increasingly capable language models. It requires reliable computer vision, spatial reasoning, simulation, low-latency hardware, safety systems, sensors, actuators, and enormous quantities of real-world data. Samsung and other major technology companies are betting that enough of these components are finally becoming viable at the same time. Artificial intelligence is also becoming a formal subject of diplomacy between the world's two largest powers. The United States and China are preparing to hold official artificial intelligence talks in September. The discussions are expected to address the risks of advanced models, military applications, cyber attacks, economic disruption, and access to powerful open-weight systems. These will be the first formal United States and China artificial intelligence talks under the current Trump administration. The timing is significant. At the World Artificial Intelligence Conference in Shanghai, Chinese President Xi Jinping presented open-source artificial intelligence as a global public good and argued that China should help developing nations establish their own artificial intelligence capabilities. China is attempting to position itself as a supporter of accessible and open artificial intelligence. The United States is emphasizing safety, chip controls, supply chain security, and restrictions on the spread of strategically important systems. However, both positions contain contradictions. The United States promotes private innovation while restricting access to advanced chips and certain technologies. China promotes open access while reportedly considering tighter controls on the overseas transfer of advanced models, training data, and semiconductor technology. The September meeting is unlikely to resolve those disagreements. It may, however, begin defining which issues both governments consider too dangerous to leave entirely in the hands of private technology companies. Frontier artificial intelligence is becoming comparable to semiconductors and telecommunications. It is simultaneously a commercial product, strategic infrastructure, a cybersecurity instrument, and a potential military capability. Finally, the artificial intelligence boom is beginning to collide with something software companies cannot simply optimize away: electricity. On July 20th, Hut 8 announced a 15-year artificial intelligence data center lease valued at approximately $9.8 billion. The agreement commercializes a 1 gigawatt campus in Texas. 1 gigawatt is not the power requirement of a normal technology office. It is infrastructure on the scale of a major power station. At the same time, governments and communities are beginning to restrict where new data centers may be constructed. New York introduced a 1-year moratorium on new facilities consuming 50 megawatts or more, while the state develops environmental standards. Amsterdam has prohibited new developments and expansions until at least 2030. New data center connections around Dublin are now required to provide their own on-site power generation. Denmark is considering placing new data centers at the bottom of the priority list for electrical grid connections. Other communities are debating restrictions because of electricity costs, water use, land consumption, pollution, and the pressure placed on local infrastructure. These conflicts will probably become more common. Artificial intelligence companies want larger models, longer reasoning, more video generation, more autonomous agents, and millions of simultaneous users. Every one of those improvements requires computation. Computation requires chips. Chips require buildings, cooling systems, water, transformers, transmission lines, and enormous quantities of reliable electricity. This is why the next stage of the artificial intelligence race may be won as much by energy companies, chip manufacturers, construction firms, and governments as by model researchers. The industry spent years describing artificial intelligence as software operating in the cloud. We are now discovering how physical that cloud actually is. Taken separately, these stories may appear unrelated. One concerns a new OpenAI model. Another concerns a Chinese startup. Others concern Google, robots, diplomacy, or electricity. Together, however, they reveal the same transition. Artificial intelligence is becoming infrastructure. Models are turning into agents that coordinate tools and other agents. Open-weight systems are becoming large enough to strain available computing capacity. Digital assistants are competing for access to operating systems, search data, and personal applications. Artificial intelligence models are being connected to industrial robots. Governments are treating frontier systems as strategic technology. And data centers are consuming enough energy to affect local planning, electricity costs, and national policy. The next phase of the artificial intelligence race will not be decided by one benchmark or one impressive demonstration. It will be decided by which companies and countries can combine capable models with affordable computation, distribution, energy, hardware, safety, and public trust. And judging by what happened this week, that race is only becoming more complicated. Which of these developments deserves a complete experiment or investigation? Should I test Kimi K3, compare GPT-5.6 with cheaper coding models, or investigate how much electricity an autonomous artificial intelligence workflow actually consumes? Leave your choice below.